Start na tayo. Introduction. Have you ever used a map that was just wrong? As in, the entire building doesn't exist on the map wrong, or it almost had me drive down a one-way street wrong. You notice pretty quickly, right? About the map where countries that are the wrong size, how do you think it would take to notice that something was off? Anyone who has ever learned geography from a map has learned something wrong. Map makers have known for hundreds of years that it's just not possible to transfer the Earth's 3D information to a 2D map without changing the shape or size of its continents and oceans. Something has to be sacrificed. The same idea is true in data visualization. Data visualization takes information from living, breathing world that we inhabit and show it to us in just a few square inches of screen or paper. That always involves prioritizing speed or accuracy or sample size or cost of another factor that are expense or something else. While the best graphs really do teach us something new and help us understand a deep truth using data, graphs can also be misleading both intentionally or unintentionally. We shouldn't ever assume that the data in visualization shows us the truth, the whole truth, and nothing but the truth. This lesson will help us recognize the elements of the misleading, confusing path graphs so that we can avoid making them ourselves. Axes and scaling are like the page layout and spacing of a paper book. They're not most exciting parts, but they do present plenty of opportunities to make it harder to read. Let's start with axis. The x-axis, horizontal, left, right, and y-axis, vertical, top, bottom. A common misleading aspect of an axis is a break. Break starts the count at the number that's not zero, or jumps ahead. This can distort the amount of difference between data points by removing context and make small differences in data seem bigger. Here's the illustration of that idea. It would almost impossible to tell a glance if there were 100, 105, or 110 people standing in a room, but you'll be able to easily tell the difference between the 0, 5, and 10 people standing in a room. Using the break on the axis can have the same effect, amplifying change rather than the context, because it alters the proportions in visualization. Check out the graphs to the right to see what this looks like in practice. So what to do? If you're looking at the graph, take a second to check where the axis starts. If there's a break, factor that in as you think of what the numbers mean. If you're making a graph instead of using big break, keep enough context to view differences in proportion or meaningful amount, or make two graphs, one without break and the other zoom in, or choose the visualization type that shows the change rather than the raw number. Scaling refers to the distance between numbers on axis. Almost all graphs are linear scale, where the numbers count up by consistent intervals, tens of a centimeter or millions of dollars. If it's the same interval, it's linear scale. The other scaling option is a logarithmic scale, aka log scale. The log scale is common for showing exponential growth that won't fit in the page with the linear scale, but it's never a good choice for a general audience. Unless people use log scales regularly, they tend to have trouble interpreting them correctly. Check out the graphs in the LE to see how the pharmaceutical company Purdue famously used this misinterpretation of the advantage in the early 2000s. The linear scale shows how concentration of the painkiller drug spikes sharply in the bloodstream at higher doses. The log scale makes it look like all doses behave pretty similarly. In general, just like it's always worth checking for a break, always worth checking how a graph is scaled. Last thing about the axis and scaling, generally we measure time horizontally, putting that variable on the x-axis. For the vast majority of circumstances, this makes the most sense and helps readers to intuit what the graph measures. Color scales. Color is often the first thing we register when looking at data visualizations. There are three types of color scales, used for the three major types of relationship we can visualize with color. Sequential scales are colors in sequence often. This is the same hue with more and more white added to or taken away from the color. Sequential scales are used to show a variable increasing or decreasing in intensity or amount, like income depth, or percent of population that owns a chinchilla. Divergent scales are anchored by colors from opposite sides of the color wheels, aka complementary colors. Divergent scale is used to visualize data where the middle is a baseline, and either side represents a contrasting change. For example, divergent scales do a good job of showing a positive-negative swing in voting or polling temperatures above below freezing, or gains and losses over time. Categorical scales use a variety of colors to differentiate categories without passing a rank or order to them. In other words, purple doesn't necessarily mean more than green. The two are just different colors. Categorical scales are for categorical data, like types of vegetables in a supermarket or different treatments, as in a controlled study, or organizational blocks on the calendar. Color associations. Once we pick the right color scale, there are still a few more considerations to be made to reduce confusions. First up, we tend to view darker colors as more and lighter colors are less. For example, if we are visualizing which US states have the most pet ferrets, California, with the most pet ferrets of any state, should be the darkest state on the map. When the scale is reversed, people will tend to just read the graph wrong, rather than reading the legend carefully. We also come to data visualizations with pre-existing associations for certain colors. We can be culturally specific, red means bad, versus red means lucky, or influenced by the norms for the particular field. Red means negative financial balance. Sometimes it's good to stick with what's recognizable. It would be confusing for US voters if a major newspaper decided to visualize Democrats in red and Republicans in blue, since these colors are overwhelmingly associated with the opposite party. But in other cases, switching up colors that have existing cultural association can reduce harmful stereotyping. Using pink for women and blue for men reinforces an outdated, binary view of women as soft and passive, and men are strong and emotional. This design choice does not only turn off some viewers, it may also distract on the graph where gender is a relevant variable but not the focus. It would be confusing to just reverse this stereotype color palette, but there are plenty of good alternatives. Check out two examples from the New York Times on the right. The important thing is consistent with alternate palette. Nakikita natin ito yung ano. Listahan. Ito yung ano, legend. Like ano, sabihin natin dalawang color. Same color, pero isa dark, isa light. Nakikita natin ito yung ano, tawag dyan. Ito yung legend. Kasi sabihin natin ano, wala tong legend. Anong point ito? Ilan bang bumoto sa kanya? Ilang lalaki, ilang babae. Kaya kailangan ng ano. Importante na may legend. Kasi dyan ma-indicate kung ano yung ano. Para saan tong ano. One color. Ganun. Next. Labels and titles. Okay. The good title is one of the best and fastest tools for making more understandable visualizations. Lots of confusion can be saved with a descriptive title. If the graph doesn't have a good title or even title, viewers have to do more legwork to first figure out what each axis measures and then what the data points show. The title can be questioned. What that visualization answers like who speaks more in Disney movies, male or female characters. Titles can also be a statement of what the visualization shows, like comparing denim in scene lengths throughout the decades, or millennials really do spend more on rent than on avocados. The effect of hunger on mood level. Like a good title, annotations on a graph also helps the viewer to understand what's going on. Annotations are perfect for calling out points of interest, explain outliers, including background information that the viewer won't necessarily know from just looking at the graph. Check out this live birds graph from Flowing Data to see how much value the annotations add. They add details to the highest lowest points of the graph, explain what the 0% baseline means, provide a KVAT for the 2021 data, reinforcing words that the persons on the y-axis show more birds and fewer birds. Just a few lines of thoughtful annotation here and they give the audience so much more ability to interpret the data at a deeper level. Ayan, nakikita natin itong graph na to. May kita na ito yung tawag dyan, flowing data. Parang, ano ba yung mas marami? Maraming nanganganak. Tapos, as years goes by, pakonti-konti na dahil mayroong nagkaroon for personal reasons naman para sa ibang tao. Kaya sabihin natin, ayun. Ayun. Conclusion. That was a short primer on some common misleading parts of database visualizations, pitfalls that get between the actual truth of the data and how the viewer understands it. People make misleading or confusing graphs on purpose and by accident. We've seen how intentional changes to the scaling that can really distort what the graph seems to say. Also how going with the status quo on color palettes can be helpful or harmful. Most of us aren't out here trying to make listing graphs. Very often, it's just a question that making better or worse decision while designing the database and improving our design skills, knowing when to use different color palettes and how to label our axes clearly. Not only will our graphs better, it also reduces bias. When we follow best practices in design, we're not going rogue. It's just making designs decision that makes the graph looks more extreme or suit our needs at our moment. We follow established practices that help to standardize graphs so that we can focus on what the data will say. Long story short, good data viz is always a combination of quality, data, and effective design choices. If we can avoid confusion or missteps along the way, that'll be a good thing.